Hi folks, this is Dr. Rob Cywes, and today we're going to talk about Alzheimer's disease and what you can do about preventing it. I am the CarbAddictionDoc, and one of the key things about Alzheimer's disease is it's very, very common, and it's increasing in its prevalence in our society. But I can quote you statistics and numbers. Ultimately, it's a very simple thing to look at. Look at your own family tree. Is your mother, is your grandmother, is your uncle, is your aunt, is your father, is your mother who has Alzheimer's disease? In my own family, unfortunately, my grandmother and my mother are both suffering from Alzheimer's disease. My grandmother passed away from it at an old age. My mom's in her late 80s right now and is getting progressively worse. And as much as I'm in this field, as much as my sister, who works at a university that some of you might have heard of in Boston, works in the Alzheimer's field, there's nothing that we can do about it. Nothing that we can do to reverse the course. And that's the tragedy. The tragedy is once you have it, there's nothing to do to reverse it. So there are, however, plenty of things we can do to predict outcome and what we can do to prevent or reduce the rate or the risk of Alzheimer's disease. And at first, I'm going to go through what our basic knowledge is of Alzheimer's disease and then what we need to do for ourselves, because there's no pill, there's no surgery, there's no magic bullet. We cause it, we can make it go away. So what can you do about it? Well, the first understanding of Alzheimer's disease is that it is ultimately an inflammatory disorder of the brain. In fact, I listened to a talk yesterday by a brilliant young scientist who's now at medical school, Dr. Nicholas Norwitz. And he gave a great breakdown on the biochemistry, the genetics, and the pathologic pathway of our current knowledge of Alzheimer's. But I'm going to break this down. I'm going to summarize it more from a what's kind of happening and how do we reverse it? How do we not reverse it, but prevent it? So the first comment is that Alzheimer's disease is ultimately an inflammatory consequence of progressive inflammatory disorders of the brain. No inflammation, no Alzheimer's. No inflammation, no Alzheimer's. And what is the source of that inflammation? Well, any source of inflammation that gets into the brain can make that difference. It could be infections such as bacterial viruses. We've all heard about the slow viruses. We remember for those of you that were alive, the mad cow's disease caused by Jakob Creutzfeldt slow viruses. Well, they got in there and caused progressive Alzheimer's. There's certain bacterial infections, polyunsaturated fatty acids that promote a non-cycling of the inflammatory cascade, the arachidonic acid cascade, releasing oxygen-free radicals from those polyunsaturated fatty acids. Glucose, excessive conversion of sugar to fat, glucose in the brain, slight brain swelling, promotes Alzheimer's disease. So we see it higher in diabetic patients. We see it in glucose-dominant patients. There's certain toxins that can promote Alzheimer's disease. Certainly trauma, a very interesting paper of women who got Alzheimer's disease had a significantly higher risk of having played soccer and heading the ball before. Blood supply, atherosclerotic vascular supply, smoking, all of those are related to the inflammatory disorders that can promote Alzheimer's. And then there is a genetic predisposition. And when it comes to inflammation, when it comes to the genetics, there's really two components. The first one is the blood-brain barrier and the integrity of this barrier that stands between the brain and the rest of the body that is very specific about what it allows through and what it doesn't allow through. And then there is this relationship between the different cells of the brain, the astrocytes, the neurons, the support structure cells, the myelin cells. All of those are necessary in an interactive relationship because the brain functions as its own unique little ecosystem. And then there are things that come from outside of the blood-brain barrier that cross that. In other words, there are certain things, certain substances that the brain needs to get produced inside the brain and certain that need to be transported to the brain. And one of the dominant transport molecules that transports fat, certain proteins, cholesterol, to make up the membranes of the brain, and membrane integrity of those brain cells is critically important in the evolution of Alzheimer's. Tissue repair, cell function is often governed by what happens on the membrane, not just the membrane on the outside of the cell, but the mitochondrial membranes, the lysosomal membranes. Those membranes are active living parts of brain cells. And the transport molecule that transports a lot of the membrane substrates to the brain is something called LDL, IDL, the lipid transport molecules that live in this infamy of causing heart attacks and strokes, cardiovascular disease. Well, those same apolipoproteins they're transport barges that transport healthy fats, phospholipids, proteins, and cholesterol to the brain for incorporation in the membrane. And as we've evolved as a species, there are certain carrier proteins that are associated with those lipoprotein molecules. And the most important one is something called the APOE proteins, or the APOE molecules. And as humans have evolved from their primate ancestors, there have been three different types of these APOEs. We call them alleles, and everybody has two alleles. They can either be both the same, or one from your mom, one from your dad. They may be different, and they confer different risks for Alzheimer's disease at a genetic level, and I'll explain to you about how that works. The one that is the earliest is APOE3. Sorry, I lie. APOE4 is the earliest of the APOE molecules. And that APOE has synergy with a lot of our primate ancestors. And the APOE4 allele is most consistent with a significantly higher risk of Alzheimer's disease. As we've evolved as human beings, we've then modified those genes that code for those apoproteins, and we've created two others. We've created E3, APOE3, which is kind of neutral in terms of Alzheimer's evolution. And then there's a protective one called the APOE2. Now, unfortunately, folks, you can't change your APOE status. It is in our genetics. But APOE4 is the dangerous one, and it is dangerous when there's a single copy, but when you have both, it is most risky in terms of Alzheimer's disease. And the way the APOE4 protein works is that it's a delivery system of certain fats to the brain, but it also has function within the brain in terms of production of certain substrates, certain fats to the brain. But it's really that transport to the brain that is dominant. And as we look at the APOE infrastructure, there's a whole genetic a cascade that goes on. I would urge you, if you're a geek and you're interested in, watch some of Errol Norwitz's work on SMHP, on our Society for Metabolic Healthcare Practitioners. He did that talk yesterday. Brilliant talk. However, ultimately what this is about is delivery of certain substrates to the brain that the brain can use for healthy development. And the single most important aspect of that are the 3 omega fatty acids, the essential fatty acids that we have to consume. The LA, the linoleic acid, and then the DHA and the EPA that are polyunsaturated long-chain fatty acids that get incorporated at a very, very high rate in the membranes, the various membranes that are in the brain. And yes, they require also insertion of the omega-6 polyunsaturated fatty acids, the alpha-linoleic acid or the arachidonic acid, but in a very specific ratio. And if the arachidonic acid ratios are high, then the inflammatory cascade, that is the arachidonic acid cascade, can damage those brain cells. There are two competing cascades, the eicosanoid cascade, which is your prostaglandins, and the arachidonic acid cascade, and they kind of balance each other out. But when one is dominant and the other isn't, especially the 6 polyunsaturated fatty acids, the omega-6s, then you get this tremendous promotion of inflammation within the brain, and very often triggered by other factors, as we mentioned earlier on. So getting the adequate DHA in your diet is critically important to this process. Now, on top of that, and this is what people don't understand, is that 25+% of the entire body's cholesterol is actually in the brain. Brain only represents about 2% of the body weight. But 25% of all the cholesterol in the human body is in the brain. And it's there on purpose. It's there as a membrane integrity molecule, as an anchor for certain proteins, for certain functions in the brain. And a little bit of the cholesterol is produced in the liver. A large part of the cholesterol needs to be consumed by the mouth. And in the brain itself, a small percentage of cholesterol gets produced. And these APOE molecules have to transport that cholesterol to the brain for utilization and then across the blood-brain barrier for utilization. So cholesterol is a crucial, critically important molecule in the brain. Think about this, folks. What happens if you block cholesterol production with a statin? Oh, but the cholesterol is so bad for your blood vessels. Well, maybe not so much. But now you're on a statin that blocks the production of cholesterol in your body, and you're on a low cholesterol, low fat diet. How the devil is your brain supposed to repair itself, especially if you've got the APOE4 gene? So cholesterol and the consumption of DHA and of 3-omega fatty acids is critically important. Then the next thing that the brain uses is saturated fat. And there really are two sources of saturated fat. One is the diet, when you're eating decent amounts of fat, and you've got longer carbon chain fats that give membrane fluidity, give membrane flexibility, that are excellent in the brain. And the brain is capable of making saturated fats. How does it make those saturated fats? From sugar. The problem is when the brain turns sugar into fat, it's producing shorter, long-chain fatty acids, called 16 and 18 palmitic acid and linoleic acid, which come from the conversion of sugar to fat. But folks, those are energy-based fatty acids. They are not necessarily the best structural fatty acids. And if your brain is making a ton of fat from sugar, it's dominated by those 16 and 18 carbon molecule fatty acids that are not in the brain's best interest. So if you're glucose dominant, if you're hyperglycemic, that's not a good place to be for brain function and for brain protection and for brain repair. Where else can the brain make fatty acids from for incorporation in those membranes? Beta-hydroxybutyrate, ketones. Ketones are also a great substrate, and ketones and sugar both cross the blood-brain barrier very readily. So those are building blocks that rush into the brain, and the brain can then use those building blocks to build healthier, better fats. And ketones, in a positive way, affect so many of the genetic and protein and enzymatic pathways within the brain, which are blocked by insulin and glucose. So on one hand, we've got a liability situation, and on the other hand, we've got a healthy situation going on. Ketones being a healthy substrate, glucose being an unhealthy substrate. The other value of ketones, because remember, the brain is in a closed box, ketones are lipids, they're fats, they don't like water. They don't need water. Glucose needs water. So on top of the deleterious effect of sugar-based fats, that sugar itself carries a bit of extra water, and just that slight increase in intracerebral pressure from that extra little bit of water puts a huge amount of pressure on the brain and damages the brain cells, activates again the inflammatory cascade. So we need ketones, we need saturated fats or non-esterified fatty acids that get delivered to the brain. We need those polyunsaturated fatty acids, and we need the substrates for them. And that is so important in terms of blood-brain barrier function and also brain function, particularly if you happen to carry an APOE4 gene, which about 30% of people in this country do. Anywhere from 30 to 65% of people carry at least one form, one allele And if you carry both, that is a 20-fold increase risk for Alzheimer's. We'll test you or help you to test for the APOE allele, for the APOE4 gene. We try not to report that because eventually life insurance and other insurance companies may hold that against you. So it's a little secret that you want to keep close to yourself. In addition, inside the brain, there's this wonderful relationship between the astrocytes and the neurons, two different types of cells in the brain that support each other, where the astrocytes are kind of a factory for a lot of these substrates, and they get transported to the neurons. They lie in close proximity to each other. And the myelin cells are the same. They contain a lot of fat. That's the whole autism talk about the development of the white matter of the brain. Be that as it may, APOE4 interferes with the production of certain healthy substrates in the astrocytes. So, having said all of this, your genetics are your genetics. What you're born with is what you're born with. But there are two huge things that you can do for yourself to radically reduce the risk that as you get older, you're going to slow down the progression of or even negate the progression of Alzheimer's. And the first thing is give your brain adequate substrates. Give your brain ketones, not by consuming ketones exogenously, but by creating a hormonal pattern in your body whereby your liver produces those ketones in the face of low sugar production. So you want low glucose, high ketone production by the liver as a substrate for the brain. The next thing is take in an adequate source of 3-omega fatty acids. Where do you get them from? Fish oil, small fish, your sardines, your mackerel, your white anchovies. The smaller the fish, and I know in this country we don't eat a lot of that, but the smaller the fish, the healthier. Or you can get it in seafood. Or if you have to, use a fish oil or a krill oil as a supplement that you take. Anywhere from a gram to 3 grams, 1,000 milligrams to 3,000 milligrams a day if you've got the APOE4 gene. If you've got the 2 and the 3, a little bit less important, but still important for other forms of dementia. So get in enough fish oil. Get in enough substrate, ketones, non-esterified fatty acids, saturated fat in your diet. And then the second thing that you can do is to restore healthy hormonal cycling. This is something we don't talk about that much, but all the hormones in the body cycle like the tides. There's an ebb and flow because it's a negative feedback pattern. As one goes up, it pushes the other down. And as this goes up too high, it gets blocked and you get the other one coming back up. So, for example, in the morning, your cortisol levels are really high, your melatonin levels are low. In the evening, your cortisol levels are going down and your melatonin levels are coming up, so you can sleep. In the morning, your glucagon levels are high and your insulin levels are on the lower side. Later in the day, your insulin levels come up and your glucagon levels come down. All of these hormones are interactive. Thyroid hormone is on a negative feedback pathway. All of these hormones function cyclically throughout the day. Well, if you're eating a ton of carbohydrates and you've got hyperinsulinemia, you're producing a lot of insulin continuously, and you've got insulin resistance, that one hormonal change throws everything out of whack because they all control each other. And if one is out of whack, now you're taking this beautiful waveform and you're creating a straight line. And that straight line changes the type of substrate you produce for your body, in particular for your brain. And when your hormones aren't cycling, your female hormones, your male hormones, your adrenocorticoid hormones, your metabolic hormones, when they're not cycling, when they're a flat line, they do not produce adequate substrate. They are not protective against inflammation, the integrity of the blood-brain barrier, and the integrity of tissue repair in the brain suffers. And you start to accumulate amyloid protein and tau, TAU, which are the two things that are definitions of Alzheimer's disease after it's occurred. Those things should be cycling in and out of the brain. And if they accumulate and accumulate and accumulate, they replace damaged and dying brain cells, particularly in the memory center of your brain. That, folks, is Alzheimer's disease. You cannot fix it at this stage. There's nothing to do to cure it. You cannot change your risk in terms of the APOE4 alleles. Your parents gave you those. But what you can do is radically reduce the negative effect of that APOE4 genome by having adequate substrates that the brain needs continuously and by restoring hormonal cycling. And if you are at risk, if you have a family member like I do who has Alzheimer's, who's going to die of Alzheimer's, if you have a strong family history, we can help you to get tested if you want to. We don't have to test you for the APOE4 allele. But if you've got a family history, it's highly likely you have 1 or 2 copies of that allele. And it is incredibly important, and at least in my belief system, to address this while you're still young and you can. Because once you're old and you've got Alzheimer's, there's nothing you can do. So the key for me is set up a visit, set up a consult, that we can figure this out, help you to figure this out, particularly if you've got a loved one, a family member with Alzheimer's. We can help you with the nutritional side. We can help you to restore the hormonal cycling. And if you want to, we can help you to get tested. Give us a shout. We do consults all the time. Text us at 561-517-0642. And you can do that on WhatsApp if you live outside of the United States. We set up virtual visits on Zoom, telephone calls. We can send you this information throughout the world. But having that consult and using that risk as motivation to do the right thing. Of course, there are other biologic ramifications in a positive way of doing these changes as well. But folks, one day when I'm really old, I want to go to bed one night and wake up dead. I want to go to bed with a complete brain and body that is functioning just fine. And the next morning, I want to be dead. That's the way I want to go out. So I'm going to do everything I possibly can to ensure that that's going to happen. Of course, I can't be absolute, but I can do my part. And that's what I'm asking you to do. If you're interested, give us a shout. Please leave comments down below. Love to hear from you, but make them thoughtful, make them funny if you want to. If you want to troll, that's fine. But let's make this a positive, empowering, collective, collaborative transformation in our thought process about an awful disease that is rising in meteoric, exponential fashion all over the world because of what we do to ourselves. See you next time. I am the Carb Addiction Doc. Thank you.